Hello everyone, welcome to OneClass. My name is Shanjida, and today I'll be going over some commonly asked math questions both at the high school slash university and college levels. And if anyone needs any additional help with schoolwork or needs tutoring services, you guys could check out the description box below. And other than that, a bit about me. I am currently a second year human biology student. And yeah, so we'll get started right now. So the first question says to evaluate the logarithm log base 4 of 16. So, so to evaluate this, what we're trying to say here is to um, basically to find what this equals to. So what I mean by that is, so if you have log base 4 of 16, right? So if you guys recall that this is basically saying y is equal to log base a of x, where if you want to find x for this, you basically have to um, you basically have to convert it into an exponential function where x is equal to a to the power of y. And so what we mean by here, by log base 4 of 16, we mean log base, so what we say here is we are basically saying log base 4 of something is equal to basically, or what this is basically equal to. So if you want to write it out in steps, what we have, since, so basically our x over here would be, so we would have to find x in this case. So we have, so let's say let y equals 16. A over here is equal to 4, and x, which we need to find. Okay, so if we have, so we know what's given here, and we need to find the value of x. So we can literally write this as 4 to the power of x is equal to 16. So since we're just writing it as, sorry, I'll just write the template formula out. Since we're just writing it as x equals a to the power of y, so we need to find x. A is given as 4. And so basically what we need to find here is y. Oops, so I'll just write this like this. Alright, so what we have to do here, we basically have to find the value of x. And in order to do that, we're gonna let y is equal to basically a to the power of x. And so y is equal to 16 here. We know the value of 4, a, which is 4, and we need to find x basically. I just interchanged the value here. We could have just y is equal to a to the power of x. Okay, and so this is what we have, and now we need to find the value of x over here. And to do that, we have to basically use ln, which is the opposite. It's basically the opposite of using a log. It's another form of log. And so we have to ln both sides of this equation. So you have, basically you're going to have ln of 16 equals to ln 4 to the power of x. And as you can see, what's going to happen next, we're going to have ln of 16 equals to x ln of 4. And now what we're going to do, we're going to divide ln 4, right? Because we want to find out x, we need to isolate x. So we can say x is, so we're going to just move ln 4 to the other side. So you have ln 16 all over ln 4. And you just simply divide ln, you simply just divide ln 16 and ln 4, which will give you x is equal to 2. So this is how you get the answer. Okay, so our next question says how to compute the inverse of logarithmic functions. And so, okay, so let's let's first define what a logarithmic function is. So a logarithmic function is basically written, so a log function is a log function is basically written as f of x, right? This means the function of x is equal to log base a, which means it could be any number of a number, so which is x, let's say. Okay, and where a is basically the base, so where a is the base of the logarithm. So usually if usually if a is equal to 10, the function can be expressed as let's say f of x is equal to log of x. You don't really express 10 as the base, you just keep it blank. And if it's other than 10, if you're using any number other than 10, for example, let's say a is equal to 2, so then your function f of x would equal to log base 2 of x. This is where you would have to write out the log. In addition, a natural when you're using natural number, let's say a natural logarithm function or a natural exponential function, natural exponential let's say e function, which is the opposite of log. So this can be expressed. This function can be expressed as f of x is equal to ln of x. Okay. So this is basically the definition of a logarithmic function. And so basically how to get the inverse of a log function, you would have to follow some steps. So the steps in order to get an inverse of a logarithmic function would be to first you would want to first of all you would want to express or replace the function like f of x or dy, f of x or y, f of x or y to x, right? So you're just interchanging the variables. So let's say you're just interchanging the variables. So in place where there's a y, you place that with an x, and vice versa. Okay, and so number two would be to replace would be to isolate the log expression on one side of the equation. So you would have to isolate the log expression. So your log expression log expression um on one side, basically. One side. Okay. And so on one side of either of the equation. And then the third step would be to convert or transform the log function to either an exponential function. So you convert log log of x, the function, to exponential function. Okay. By using the following property, as we discussed earlier, how log, if you have y is equal to log base a of x, this will then become your x is equal to a to the power of y. Okay, this is your exponential function. The fourth step would be to solve the equation. So you have to solve the equation in terms of y. Okay, so you would have to find the y to find the y function to get its inverse. Okay, and then lastly, the last step would be to basically replace or like rewrite replace y by the inverse function notation, which is f inverse of x. So this is how you write the notation for an inverse function. Okay, and so basically, if you want to have a solution here or an example, we can have an example. So for example, let's say we have a function that is find inverse of this function of of f of x is equal to log base 3 of x plus 2 minus 4 is 2 minus 4. Okay, and so the first step would be to replace the function notation or y and vice versa. So the first step would be to change f of x and x. So you would have, so this function would be x is equal to log base 3 y plus 2 minus 4. So you're just interchanging the variables. So the next step would be to isolate the logarithm to one side. So what you would do is you would basically move everything. So you would move. So basically, you would move the minus 4 to this side, and so you would have x plus 4, right? If you move the 4 to the other side, you change its sign, and you have log base 3 and y plus 2. So this is your log function, right? It contains the y that you're trying to isolate or find. So the third step would be to convert this log function into an exponential function. And to do that, so you have x plus 4 is equal to log base 3 y plus 2. If you recall, you would want to express this into a exponential function. You would have to do it like this. So it's going to be log, right? A to the power of y, which is x plus 4, is equal to your x, which is your x in this case, right? Is this y plus, right? So basically, this is coming from y is equal to, or right, it's x x equals to a to the power of y, right? And so this is so after doing this, when you're done converting it into an exponential function, the next step would be to solve the equation by finding y to get the inverse, right? So the way you would do this, so you have 3 to the power of x plus 4 is equal to y plus 2. And so to solve for y, you would just have to move everything, whatever is attached to it, to the other side. So you just have to move the 2 over, and you have y is equal to 3 to the power of x plus 4 minus 2, right? And so the last step would be to replace y with the inverse notation, which is f inverse of x is equal to 3x plus 4 minus 2. Okay? And so this is how you would basically, these are the simple steps to follow in order to find the inverse of any log function. So yeah, we mentioned the steps and we use the example. And as shown in the graph, so this is a graphical representation of how an inverse function look like. So you can see that a line, a asymptotic cross here, and these are these are the inverse functions. They're basically the opposite. Okay, and so this is correct. Our next question says, how do you solve the compound inequality? Okay, so we have got an inequality here. And so basically to solve this, we just need to apply some algebraic operations. We are using all the operations here, which are like your subtraction, addition, division, and maybe multiplication. And also when you're dealing with inequalities, you have to remember when you're changing sides, either from equal, from using negative numbers to positive numbers, your signs change when you're going from either side of the equation. So in this case, we have 22, this inequality here, -7. negative. And so the first step would be to so we're solving for x here. So you basically solve for x, right? And so since we're solving for x, we just have to basically um move everything that's attached to it. In this case, it's -7 to both sides of the equation. Okay, and to do that, we basically have to add 7 on each side since it's negative, right? When we're changing sides, we use we use the opposite operation. And so to do that, you can just say on this side is going to be 22 plus 7 -5x minus 7 plus 7. And over here you have plus 7 plus 7, right? So over here you have 22 plus 7, which is going to be 29. And over here you just have -5x. And over here you have 4, right? So keep in mind whatever you're solving for. In this case, we're solving for x. So whatever it's attached to, for example, like we're just looking at the middle term here, is attached to -7. You have to move -7 on both sides, and remember to change the sign since it's going on both sides of the equation or the opposite side of the equation. So you always have to change the operation. Okay, so the next step would be to isolate. So we're still isolating x here, and to do that, we have to remove the 5. As you can see, it's in multiplication terms. So when we move it to the other side, it's basically going to be dividing in both sides. So we're just gonna move the -5. So we have 29 over -5 x. And also keep in mind, we're not changing the equal signs or the greater signs in this case. That's very important as well. And then you have 4 over -5. So now what we're gonna do, we're just gonna now solve this right here. And what you have, so we're just gonna still leave this as a fraction because you can't simplify this even more. And now what we're gonna do, we're going to change the signs, the inequality signs, to the opposite of what it was because we're dealing with negatives here, and it's going from negative to a positive, so you're changing signs. And so you have x here and then greater or equal to 4 over -5, right? So since your x basically changed from a negative to a positive, your inequality signs also change. Okay, so basically we're finished solving the inequality. We can further simplify this. If the question asked for decimals, we can write this in a decimal form by evaluating this even further, which is, so 29 divided by -5 is -5.8, and 4 divided by -5 is -0. So this is how you solve the inequality. This is solution. Okay, so our next question here says, how do you simplify negative exponent in fraction? Okay, so negative exponents are basically defined as the multiplicative inverse or the reciprocal of the base. So what we mean by that is, so basically we have a formula here where let's say you have a negative exponent, x to the power of negative n is equal to, so you have a negative exponent here. So a better way to represent this, since we don't want to really use negatives in our equations, so a better way to write this is you representing it as a fraction, or this is what it equals to, x to the power of n. So this is how you basically represent a negative exponent function. If you have a negative exponent, it's basically the reciprocal of that. And so for example, where n could be any negative number except 0. And so what you have to do, so this is just simply applying the negative exponent rule, which is moving the negative exponent in the denominator to the numerator, and the negative exponent in the numerator to the denominator to transform the exponents into positive. So basically, as you can see, we took the reciprocal, so took reciprocal, right, and it became a negative to a positive, right? And so we have, there's a basic, another basic function or rule where if you have a fraction of x to the power of negative n over y to the power of negative m, this is basically equal to y to the power of m over x to the power of n. So in this case, you guys can see that we changed the numerator with the denominator. And this is very crucial in this step. This is a basic rule. Your denominator will go to the numerator, and the numerator will go into the denominator. It's just like how we did it in this case, right? It will go to your numerator, will go into the denominator always. And so this is basically how you turn it into a positive, a negative exponent to a positive exponent. And for example, we can do an example here. So example, if you have basically, let's say 4 to the power of negative 5, right? And we have to express this, so express as positive, as a positive exponent. So we just have to basically use the simple steps, right? That we just went over. So this is basically the one that we just went over, the first example, where this is x, this represents x to the power of negative n, and you know that this is 1 over x to the power of n. So you can say that 4 to the power of negative 5 is equal to 1 to the power of 4 power of 5. Right? So you can further simplify this or leave it like this by saying, so you can just compute 4 to the power of 5 is 1 over 1024. Okay, so this is how you would express, or if it said just to express as a positive exponent, then you would leave your answer like this. Or if it said to simplify and evaluate, then you would have this as your answer. Okay, so this was for example 1, and for example 2, we can have, for example 2, we can have, let's say, simplify simplify. So let's just simplify 2 to the power negative 3 over 7 to the power of negative 2, right? Um, so from our equations or formulas that we have, this resembles x to the power of negative n over y to the power of negative m. And as you guys should remember that this would be y is equal y is which equals to y to the power of m over x to the power of n, and they're both positive exponents. And in this case, your denominator and numerator flips. So in this case, to the power of negative 3 over 7 negative 2, this would flip. So it would be 7 to the power of 2 to the power of 3. And if you want to evaluate this, this basically goes to 49 over 8. We can't further simplify this. And so this is how you and the solution is correct. Okay, our next question says, which of the following equations can be simplified to find the inverse of y equals to 2x squared? So our question says inverse of find the inverse of y equals to 2x squared. Okay, and we're given options here, and we're trying to find the inverse of this equation. Okay, so to find the inverse of this function or any function, as we previously discussed, we have to interchange full solution. Okay, so first step would be to interchange the variables. Okay, and so to interchange the variables, once we've done that, we would get, so since in this case we have y is equal to 2x squared, we interchange the variables, we would have x is equal to y squared. Okay, so now we can solve for y and find its inverse, right? So in this case, we're solving for y instead of solving for x. So when we solve for if you solve for y to find the inverse, we can, or sorry, we're just trying to find the value of x here. Since we're trying to find the inverse, in this case it was y is equal to something, in this case x is equal to something, and so therefore so this is the inverse of that function. Okay, and so this is the inverse of y is equal to 2x squared, and from the given options it looks like it's C. Yeah, so this is correct. Our next question says, what is the solution of the equation 4x squared is equal to negative 9x? So 4 x squared is equal to negative 9x minus 4. Okay, so in this case, what we're trying to do is find the value of x in this case. So to do that, what we need to do, we have to first make this into a proper equation, a proper polynomial equation. And to do that, if you guys recall the basic outline of a polynomial function, which is ax squared, in this case, plus bx plus c is equal to 0. So we have to convert this into this, okay? And to do that, we would have to basically move, everything that's on the equal side on this side to the left-hand side. So we basically get 4x squared plus 9x plus 4 is equal to 0. Okay, so I just moved everything on the side to the side because it would be easier to not deal with negatives, and so then it equals to 0. Right now, this is basically a common factoring question, but we have to first see if we can factor this out using simple factoring method. So if you guys recall that to do that, we first have to find two numbers that multiply into 16 and add, right? Add to 9 in this case. So the only multiples of 9 are 3 times 3 times, or 3 plus 6, 5 plus 4, and 9 plus 0. In this case, we can't do it. So, and none of them, if you multiply them, you can't get 16. So in this case, what we have to do is we have to use the quadratic formula. So we have to use the quadratic. Okay, so the quadratic formula is x is equal to negative b plus minus square root b squared minus 4ac over 2a. Right? And in this case, we can say that this is our a, b, and c, right? So using that, or keeping that in mind, we can find x. So we just substitute the values in. So b was 9, so in this case it was negative 9 plus minus square root of 9 squared minus 4. A is also 4. B is also 4. They're all positive. Right? They're all positive. And this is all under 2. Okay, and so once we have put everything into our equation, we can just simplify this or evaluate it, and we get negative 9 plus minus, evaluate what's under, so you have 81 minus 64 all over 8. And now, if you evaluate the stuff underneath the square root, you have 17 all over 8. And since we can't further simplify root 17, we're just leaving that as it is. And then what we're going to do, we're going to split this equation into 2. Since you can see there's a positive and a negative, so we're going to say we're going to let x1 is equal to negative 9 plus square root of 17 over 8. And then we're going to say x2 is equal to -9 minus root 17 is equal to 8. And so this is basically saying the same thing as 17 minus plus oops minus okay, this is the same thing as saying -9/8, and we could just leave the answer like this. Okay, and so basically this is the answer of how to evaluate or find the solution of this equation. Okay? And yeah, so you let a is equal to 4, b is equal to 9, c is equal to 4, and yes, so that's okay. So our next question here says um says unless the quotient of a number is 3. So now we have to find this is we're trying to find out a number that is 10 less the quotient of a number, and 3 is 6. 10 less the quotient of a number. What is the number? Okay, so first let's address the number that we're trying to find is let x equal the number or number. Okay. Um so we always have to set a variable to an unknown. And then next, since we're talking about quotient of a number and 3, so what this means is that we're dividing the number by 3. So whenever you see quotient means you're dividing. And so then we can express this by x over 3, the number we have equal divided by 3. Okay, so this is your quotient of a number in 3. Okay, and so then it says 10 less the quotient of a number and 3. So 10 less of a quotient of a number and 3. So you can imagine that 10 less means 10 subtract x over 3, right? So this means 10 less the quotient of a number and 3, right? So this is how you would express that. And then the next piece of information that we have says so then it says number. So the next part that says a quotient of a number and 3 is 6. So is 6, from that we know that it is equal to 6. So what we can say here is that 10 minus x over 3 is 6, means this is equal to 6. And so this represents 10 less the quotient, of a number and 3 is 6, right? And so basically this is the equation that we have got. Now we just have to solve for x. So we just say solve for x. Okay. So this is basically simple isolating. And well, now what we have to do, we have 10 over 3 is equal to 6. And so what we want to do here, we basically want to, basically what we want to do here, basically we want to get everything that x is attached to onto the other side. And to do that, we can first move x divided by 3 to the other side since it's negative. So we can have, and so that 6 comes over to this side and will become negative. So you have 10 minus 6 is equal to x. Okay. Since this is, so what I just did is just moved the x over 3 to the other side since it's negative. And so x over 3 is by itself. You can compute this. 10 minus 6 is 4. And you have x over 3. So now, as you guys can see, that there's 3 divided by 3 that is attached to x. So we have to move it to the other side. And since it's in a division state, when it goes to the other side of the equal sign, it will basically change its operation and become a multiplication. So what we have, so we basically move this to the other side, and you have 4 times 3 is equal to, right? And so what you have, so you 12 is equal to x. And so your answer, so the number that you're trying to find, what is the number? The number x is, okay. Yes, number is 12. Next question says, which second degree polynomial function f of x has lead coefficient of 3 and roots 4 and 1? Okay, so we're given 4 options here, and you guys could probably say that or see that all of them have a coefficient of 3, and now it's a matter of fact to find which ones have the roots of 4 and 1, which means x is equal to 4. Which ones of them will equal x equal to 4 and x equal to 1? And so to do that, so what we mean by that, say roots, so roots, given roots, or the roots that we need to find are x is equal, or x minus 4, x, which is equal to 0, right? So the way to find the roots, in this case, x is equal to 4 and x is equal to. So so in this case, the way you would want to write it is the way you would want to write this out would be f of x. Since we have a coefficient of 3, you would write it, you would write 3 first. Then you would have x minus 4, x minus 1 as your roots, right? This is basically, we're going backwards. Instead of factoring, we're foiling in this case, so we're going backwards in terms of factoring. Okay, and so we would use the FOIL method. So we would, and then it would go on. And so to FOIL this out, we can basically we can first FOIL out the brackets first. So this, 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 and this, right? And so what we have, so I'll just 3. So you have x squared minus x, 4x plus 4, right? If once you FOIL it out, so now you just have to add this. 4 minus 4x minus x is minus 3x, 5x minus 5x plus 4. Okay. Now it's just, we just have to distribute the 3. So you have 3x squared minus x plus 12, right? And so from the given options, we can say that the answer is B. So we can say, therefore, there is next question. Says find the first 6 terms and the 6th partial term of the sequence whose nth term is the given sequence. Okay. And to do that, so we're given a geometric sequence, and we're given the basically the the sequence formula, which is a n is equal to 2 and minus, right? So we just have to find the 6th term, and so we just have to plug in. So recall, we just have to plug in 1, 2, 3, 4, 5, 6 into the equation as n. So in this case, n would be 1, and we have to do this in steps. So oops, n is 1 squared minus 1, right? And so this would equal to 1. Then we do the same thing for a 2, and you have 2 squared minus 1, and this will give you 6. A 3, what we can't do is go right to 6, is because we need all these individual numbers, and that would give you the partial sum. In this case, we're trying to find the partial sum as well. So you'd want to not directly go to a to the 6. So this is why we have to break it down and use we have to do all the steps. In this case, oops, this is basically 2 minus 3, and this would equal to 17. A to the 4 minus 4, and this would equal to 8. And a to the 5 and you get here 45. And lastly, a as a 6th term, get 2, 6 squared minus 6, and this equals to 60. Okay, so therefore the 6th term of the sequence, so you can say therefore Therefore, the first six terms of the sequence are um one it's 1, 6, 17, 6, 17, 45, 28, 45, 28, 45, and 66. Okay, and so we can now find the sixth partial sum of this sequence by adding all this up. So sixth partial sum. Into this, we just simply add all the sequences. Plus 17, plus 28, plus 45, plus 66, and you get 106. And so thus sixth partial sum is 163. Okay, and as you can see, solution is correct. Okay, our next question says, what is the factored form of x n to the power 4 minus, let's suppose minus 24 n to the power 3. Okay, so let me write down. So we have x by 6n to the power of 4 minus 24 n to the power 3 plus 18n, right? So to factor this, you can see how there is a common, two common things. This equation has n in all the terms and it's divisible by 6. So we can basically take out 6n, and you're left with n cubed minus 4n squared plus 3, right? And so now the question that we have is n cubed minus 4n squared plus 3 is still factorable, okay? And in this case, we use the remainder theorem, which tells us that, so now we use remainder theorem, which tells us if p of x, or p of n in this case, is equal to 0. Okay, and so now we can basically use trial and error to find n, or the roots in this case, which of them is equal to 0. So in this case, we can say Pn is equal to n cubed plus 1 minus 4n squared plus 3. right? And so we can just use trial and error and use different numbers to see if it equals 0. So in this case, let's just say 1. We can't use 0, as you know that if you use 0, then we would still have plus 3 at the end. So 0 won't work. So we can use 1 cubed minus 4, 1 squared plus 3. So you have 1 minus 4 plus 3. So 1 minus 4 is negative 3 plus 3 is 0. So is a factor. So hence you can say hence n minus 1 is a factor. So we can find the other roots as well by doing simply division. And so we can say that n cubed minus 4n squared plus 3. And if you divide this by n minus 1, you get, so you basically just divide. So you would have n squared minus 3n minus 3, right? Just dividing it. And so you can say, therefore, the factor in this case, so your end result would be, so therefore the factor is 6 and n minus 1 n squared minus 3n minus 3. Okay, this is distributed. Okay, so our next question here says, how do you simplify question here says, how do you simplify 3x minus 2 squared? Okay, so simplify 3x minus 2 squared. Okay, so this is the squaring a binomial, and if you guys can recall, this looks like a minus b squared, where this is equal to a squared minus 2ab plus b squared. So to simplify this, we can basically rewrite this as 3x squared by just basically saying that a is equal to a and this is b. So you have 3x squared, or you don't have to. And number 3x squared minus 2, 3 is 2, plus b squared, which is negative 2 squared. And so then what you have, once you simplify this even more, you have 9x squared plus 9x squared plus 12x plus 4. Okay. And so this is this should be the answer. Okay. Okay. And so this should be your answer. Um, and so let's say that is the answer should be 9x squared plus 12x squared. Okay, guys, so that was the end of our session. If you guys like this Q&A, please give it a like and subscribe to this channel. Other than that, I'm Shanjida, and if anyone needs a one-on-one tutoring session or has any personal question, you guys could check out the link below and ask your question. And I'll